Welcome to the first lesson of a topic titled Exponential and Logistic Functions. Lesson 1A focuses on exponential functions. We'll learn about exponential functions, the standard form for the equation, and a basic graph. We'll also learn how to use a table of values to write an exponential model and identify transformations. I'm Mr. Stark, and this is Exponential and Logarithmic Functions. Let's get started. We study exponential functions because they model a lot of different situations, like population. Think about this with me for a moment. If the population of Austin, Texas increases by 10% every year, what will the graph of the population look like? In order to visualize that, you might need to visualize a linear function first. So if the population of Austin, Texas increases the same amount every year, that would look like a line. But if the population increases by 10%, we have a compounding of the population. That must mean it looks like a curve. This curve could also model compound interest or the growth of bacteria. The standard form for an exponential function is f of x equals a times b to the x. I say that the way that I did because I have a warning for you. Don't be tempted to combine the constant in front with the exponential portion of the function, especially when you evaluate the function. Let's talk about that model a little more. A and b are real constants. B is not equal to 1, otherwise it would be very boring to study. B is also positive and it's called the base of the exponential function. A is not equal to 0, otherwise it would also be very boring to study, and it's called the initial value of the function. So f of 0 equals a. If you plug in 0 into the function, you get a. And you could see that on this graph. That's it for now. We'll study another equation like this in the next lesson. Now let's study the table of values for two different functions and see if we could write the exponential model for them. Let's look at f of x first, and I want you to think along with me. So the first y value is 4/9, then 4/3, then 4, then 12, then 36. What do we need to multiply 4 by to get to 12? And what is that number we multiply 12 by to get to 36? 3. Since we're counting in a times 3 sort of way, the base is 3. And notice that works for 4/9 and 4/3 as well. 4/3 times 3 is 4. Now let's figure out what a is. Remember, a is the value that when you plug in 0 for x, you get a. And notice for f of x, that's 4. So based on the model above, f of x can be written as 4 times 3 to the x. Let's do the same thing for g of x. Think along with me. How do we get from 128 to 32? We have to divide by something or multiply by a fraction. How do we get from 32 to 8? That's a little easier. 32 divided by 4 is 8. So we have to multiply 32 by 1/4 to get to 8. Let's see if it works for the other ones too. 8 times 1/4, 8 divided by 4 is 2. Great. 2 times 1/4, 2 divided by 4 is 1/2. If we count in a times 1/4 sort of way, that means the base, or b, is 1/4. To find a, we go to the table of values, we plug in 0, and we get 8. Therefore, g of x can be written as 8 times 1/4 to the x. Now it's time for you to explore some basic exponential functions on your own. For number 1, set your window to -2, 2 for the x values, and -1, 6 for the y values first. Then graph those 4 functions. See if you could figure out which point is common to all 4 graphs. Then analyze the functions. Rinse and repeat for number 2, where those functions have fractional b values. Now would be a good time to pause. The last thing we'll do together is identify transformations of exponential functions. We have 3 functions to check out. g, h, and k. So let's look at g first. I notice that 1 is being subtracted from x. And that's happening on the inside of the function, meaning it affects the x value. So compared to the function 2 to the x, 2 to the x minus 1 is shifted to the right 1 unit. For the function h of x, I notice that x is negative, which is also on the inside of the function. So that negative sign affects all of the x values. It makes every positive x negative and every negative x positive. So it's a horizontal reflection, meaning it's reflected over the y-axis. Finally, we have the function k of x. And I notice a 3 that's being multiplied by 2 to the x. Well, that 3 is on the outside of the function, so it affects the y values. It makes every y value 3 times bigger. So compared to the function 2 to the x, k of x is a vertical stretch by a factor of 3. And that is the first lesson of the exponential and logarithmic functions unit. I'm Mr. Stark. Join me for the next lesson, lesson 1b. Did you press that subscribe button yet? Give me a thumbs up if you liked the video. If you have a question, you might as well ask it. Do you have a comment? Feel free to add it. Hey, thanks for watching.